Determine the shear and moment diagrams for each member of the frame. Assume the joint at A is a pin and support at C is a roller. The joint at B is fixed. The wind load is transferred to the members at the grits and purlins from the simply supported wall and roof segments. To solve this problem, we'll be solving it in individual sections. Let's draw the free body diagram of member AB. A is a pin connection. At A, it's going to exert 17.5 pounds of force. In the center, there's going to be 3,500 pounds of force. And on the top section at B, there's going to be another 1,750. The reason the force vectors are like this because of one-way system. You can go back to previous videos if you don't know what a one-way or two-way system is for load transfers. Alright, back to the problem. At B, it's a fixed connection. There's going to be horizontal and vertical reactions. And then there's going to be moment. We're going to begin by summing the forces in y direction. We have By, and then we have our Ay. Both of these are equal to 0. Solving it further, we know Ay is equal to By. This is going to be our equation 1. Then we're going to sum the forces in x direction. We're going to have positive 7,000 pounds force, and then negative Bx, positive Ax, negative Ax, all equals to 0. This is our equation number 2. Then let's sum the forces. Then going to take moment above the point A. Going to take a moment above the point A. I'm going to have 3,500 clockwise, 7 feet away. Then 1,750 clockwise, 14 feet away. Counterclockwise Bx, 14 feet away. And clockwise moment B equals to 0. This is equation number 3. I'm going to proceed to member number 2, which is our BC. So at member BC, we're going to have CY, which is a roller. Pardon me, it will be CX in this case. And we're going to have a BX, BY, and my moment. And then there is external reaction forces. So there is perpendicular reaction forces at 3 points. First one is 300 times 3.5, which is 1,050. So it's going to be on the other side of this at C, and the middle one is going to be 2,100. Alright, now that we have all the vectors, we can start solving. So let's solve, first of all, more reaction forces in the x direction. Going to have Cx, negative, positive Bx, and then we have combined load, which is going to be positive sine 30 times 4,200 equals to 0. This is going to be our equation number 4. Then we're going to sum the forces in y direction. Going to have By, then negative cos 30 times 4,200 equal to 0. Cos 30 times 4,200 is equals to 37.307. Now that we have By, we also know our Ay, which is 37.307. And now I'm going to take a moment about the point B. Going to have more positive moment B, clockwise 2100 at 7 feet, clockwise 1050 times 14 feet, and then sine 30 times Cx equals times 40 equals to 0. This is going to be equation number 5. I'm going to go back to equation number 4, solve it further. With respect to Cx, I'm going to have positive Bx positive 2100. I'm going to plug the value of Cx into equation number 5. I'm going to have moment B plus 14,700 negative 14,700 negative 14,700 and then we had a positive here, I believe, because if we look here, Cx is 30 degrees. Yes, so it's going to be positive because it's counterclockwise. So positive 7Cx equals to 0. Plugging the value of our Cx, going to have moment B. This is going to be negative 29,400 plus 7Bx and positive 2100 times 7 is 14,700 equals to 0. Simplifying for moment B, we can have our solution as negative 7Bx and then positive 14,700. Now we're going to plug this value of the moment B into our equation number 3. We're going to have value of moment B as positive 7Bx and then negative 14,700 equals to 0. Solving for Bx, you're going to have our solution as 3033.333 continuous. Now that we have value of the Bx, we can plug the value of the Bx into our equation 4. And we're going to have our value of the Cx, which comes up to be 5133.333. And now we can also plug the value of the Bx into our equation 5 to find our moment B. Well, this is going to be 3033.333 times negative 7 plus 14,700 gives us negative 6533.333 continuous. And finally, we can plug the value of the Bx into equation 2. And we get the value for Ax as 3966.667. Now that we have all the required values, we can plug these values into our shear and moment diagrams and get our final solution for the problem. We are going to begin with the shear diagram. Our shear diagram starts with the value of Ex, take away 1755, so In this case, we already have the value of Ax as 3966.667. Take away 1750. This means we're going to begin our journey for shear at mark of 2216.667. From there, nothing's going to happen for 7 feet. Then we're going to get bumped down by 3,500 pounds, which will bring us down to negative 1283.333. And from there, again, nothing's going to happen for 7 feet. At this time, we're going to have two conflicting forces just like before. So we have 3033.333. Take away 1750 gives us 1283.333, which will bring us upward to our zero mark. And this is our section AB. And now for BC. For BC, first of all, before we do our equation, we'll have to convert our vectors into force vectors that are perpendicular to our beam. To do that, we know that the angle in between here is angle theta, which is 30 degrees. Now to convert our load to this B prime and C prime, we simply have to convert our vectors into point loads. To do that, first of all, we have our vertical load By. So this is going to be cos 30 degrees times the value of By, which is 37.307. And then we have a negative vector sine 30 times our Bx, which was 3033.333 continuous. And then finally we have this load, which is negative 1050. Solving for this, we get our solution as 0.3333 or 4, you can say. And then we're going to do the similar method for our C prime. In this case, it's going to be, we're going to take cos 60 degrees times 5133.333 continuous, take away 1050. Solving this, we get our solution as 1516.667. Now we can get back to our shear diagram. So our B prime, which we found to be positive 583.334, takes us upwards. And then from there, nothing's happening for next 7. And then we get pushed down 2100 pounds, which takes us to negative 1516.666. Again, nothing's going to happen for next 7. And at that point, C prime is going to push us upward to the zero mark. Now we can do our moment diagram. Moment diagram for this problem is super simple. So for a moment at A, we're going to begin at 0. Then we have this positive area, which is 2216.667 times 7 gives us our peak value of 15,516.669 first order curve. And then we have this negative area, which is going to be negative 1283.333 times 7 gives us negative 8983.331, take away 1516, we get down to 6533.338, first order curve. And from here we have our moment 6533.333, which will bring us down to 0. That means our moment is correct. And now for the second part, we have this positive area, 583.334 times 7 gives us our peak for this section, which is going to be 4083.338. And then we have this negative area, which is negative 15. Oh, and one thing I missed. Before we do this, we have a positive, negative, because it's a counterclockwise, but we have a negative moment B, which means this will be clockwise. That means we are going upwards. So we're going to go upwards 6533.338, and then we're going to have this positive bump of 4083, which will be taking us upward to our peak of 10,616.7676. And then we have our negative curve or area, which is going to be negative 1516.666 times 7 takes us all the way down to our 0 mark.